Let's take a look at section 7.6, assessing normality. We've spent a lot of time doing the normal distribution, looking at the normal distribution. We looked at the sampling distribution. We're going to be spending a lot more time calculating stats based on normal distributions. So it's worth taking a moment to say, well, when do we know that we're talking about a normal distribution? And in particular, what about given a sample, do we know that the population is normally distributed? Or do we have a good idea that the population should be normally distributed? And so that's what we're going to do. We're just going to build a little intuition for that here. Now, a couple things to keep in mind. No distribution is perfectly normal, not in real life. So we're looking only for approximate normality. Right? When determining whether a sample comes from a normal population, we're concerned primarily with small samples here, and that's because the central limit theorem states that large samples, meaning samples of size greater than 30, have an approximately normal distribution, right? The sampling distributions are normal, right? And what we're trying to do here, as I just said, was develop an intuition. We want to develop an intuitive observation skills rather than, I guess, exact formulas. Right? Because we don't want to think that a distribution is normal when it's really not, because then all the analysis we do on it in the coming weeks won't be correct. Okay? So here's a fact. We reject that population is approximately normally distributed if any of the following are true about a sample. Number 1, the sample contains an outlier. Number 2, the sample is heavily skewed. Right, if there's a big tail. Number 3, the sample is not unimodal, right? I.e. has multiple, you could say multiple modes, but that could be a little misleading. Multiple peaks is what I would say, or, humps on the graph. Maybe I won't say humps, that's a little ambiguous, right? And if a sample has none of these characteristics, then we assume its population is approximately normally distributed. Right, and then it's nice because then even if it's a small sample, we can still use the central limit theorem and use the sampling distribution stuff and blah blah blah. Okay, so we're going to consider the following examples using dot plots, histograms. What was the next one? Stem plots, or stem and leaf plots, and then we'll end with box plots or box and whisker plots. Just to determine what's going on here, whether we're talking about a normal population. So suppose we take a sample of size 5, and this is the sample that we get. Is it reasonable to think that the population is normal? No. Population is likely not normal because sample contains an outlier. Right? Here the population is likely normal. I should say is approximately normal because the small sample contains, I should say, no outliers, isn't skewed, isn't like strongly skewed, and appears unimodal. Okay. Let's take another look, right? Now look at histograms, right? Well, if you look at this, is it perfectly normally distributed? No. Is it perfectly symmetric? No, but it does have this rough sort of shape to it. So, yes. So yes, the population is approximately normal, right? For the reasons I listed above, right? No outliers, no skewness, no bimodality. Technically speaking, there's a little bit of bimodality. No, not really. That's approximately normal, okay? Compared to this is really golden arches right here, right? No, population is not normal, nor is it even approximately normal, because the sample is bimodal. It's not unimodal, right? Consider this stem and leaf plot. Does this population look approximately normal? Well, if you sort of sketched it a little bit, like, no, right? There's a bit of skewness going on here. No, I'll say the population is not normal because the sample is skewed right. Right? And that suggests that the population might be skewed right. The population distribution might be skewed right. Okay? Compared with this box plot, on the other hand, where now this is roughly symmetric. This looks okay. I should say is approximately normal. Okay? Now, it's worth noting that with box plots, you don't have a way to check bimodality. Think about it. You have a way to check symmetry. This appears to be symmetric, but you don't actually know that the data isn't bimodal. So that's just a limiting factor with box plots. There's nothing to be done about that, right? If you want more specificity, look at the data set or look at another one of these graphs, like a histogram or something. Okay. Now, there is one more way that we can check approximate normality, and that is called QQ plots, which use z-scores to determine whether a sample comes from an approximate normal population. The book has a lovely explanation, lovely detailed explanation for how they work. We don't need to worry about that. We're going to worry about just the visual, intuitive aspect of all of this, okay? So if we consider the following data set, looking at it, I'm not totally sure whether it's a population is approximately normal based off of the data set. So what we're going to do is we're going to open Excel, not Minitab, just Excel. Type the data into the column in the, I think it's called Normality test, is it? Which worksheet? Yeah, test normality. In the test normality worksheet. Okay, and then you can go ahead and ignore all of this. This is a little outdated, right? We don't need any of this stuff right here. Okay, and then what we do is we go ahead. It's lovely that they give us a box plot, very nice. But we're really interested in this QQ plot right over here. Oh, never mind. So they actually put the hyphen for QQ plots. They actually put it like this, QQ plot. There you go. And all you're looking to do is just see, do these dots seem to hug the line? Do they follow a roughly linear pattern? Of course, it's not going to be perfectly straight line, but do they roughly hug the line? If so, then the population is approximately, oh my gosh. Normal. Okay. If not, then the population is not approximately normal. All right. So in this case, yes, this population is approximately normal. Because the points roughly hug the line. If they had some kind of circular shape like that or curvy shape like that or something like that, they weren't really following a linear trend, then the data set would not be from an approximately normal population. And that's what we've got.